The roots of the atomic theory begin with a man named Democritus. Now, Democritus was a Greek name, and of course he was born in Greece. This part of Greece exactly. Abdera, Greece. Democritus was known as the laughing philosopher. He lived from about 460 BC to 370 BC. During his life, he liked to travel and learn. He met a man named Leucippus, who became his teacher. Together, they created the basic roots of the atomic theory. They theorized that if an object was cut in half enough times, there'd be something that could not be cut anymore. They named this atomos, for indivisible in Greek. His theories, however, were not accepted until thousands of years later when a man named John Dalton came along. John Dalton was born on September 6, 1766, in Eaglesfield, England. He died on July 27, 1844. John Dalton was the first person to prove the existence of atoms. He used math and science to determine the existence of atoms. Using the laws of conservation of mass and the law of constant composition, he proved that atoms did indeed exist. He then also created rules for atoms. There are 5 main important rules. 1. Everything is composed of atoms, which are the indivisible building blocks of matter and cannot be destroyed. 2. All atoms of an element are identical. 3. The atoms of different elements may vary in size and mass. 4. Compounds are produced through different whole number combinations of atoms. 5. A chemical reaction results in the rearrangement of atoms in the reactant and product compounds. Then, in the 19th century, a man named J. Thompson was born. He was born in Cheetham Hill, Manchester, on December 18, 1856. He used an object known as a cathode ray tube to determine the charge of a cathode ray. A cathode ray tube is a weirdly shaped piece of glassware that looks like this. There were 2 pieces of metal at the end, and the air had to be pumped out of the cathode ray. J. Thompson then connected the 2 metal plates with a power source, and it shot out a ray. This was known as the cathode ray. To test what charge the ray had, he put a negatively charged magnet on one side and a positively charged magnet on the other side. He shot the ray again, and it bent towards the positive magnet. This signified that the cathode ray was negatively charged. Cathode rays were eventually renamed to the more familiar electron. Thompson believed that the electron was thousands of times smaller than the atom. He created the plum pudding model, proposing that the plums scattered within the atom were negatively charged, and the pudding was positively charged. J. Thompson had a student, Ernest Rutherford. Rutherford was born on August 30, 1871 in Brightwater, New Zealand. He died on October 19, 1937. He is most known for his gold foil experiment. He was trying to use the experiment to prove Thomson's plum pudding model, but instead found even more about atoms. He shot positively charged alpha particles into the gold foil. He expected the alpha particles to rip through the atoms like a bullet would pierce through a shirt, and that's how it went for a little while. Then one particle hit the gold foil and bounced back. Rutherford then concluded that the atom had a very small but heavy nucleus. He also knew that the nucleus was comprised of positively charged particles. He named these protons. Using this newly learned information, he created a model called the planetary model. It depicted protons at the center as a small heavy nucleus and electrons orbiting around it. A decade or so Rutherford's junior, Niels Bohr, was born on October 7, 1885, in Copenhagen, Denmark. He died on November 18, 1962. When studying the planetary model of Rutherford, he realized that if the electrons were to give off radiation continuously, the electrons would be sent spiraling into the nucleus. Hence, atoms could not exist. He proposed the Bohr model, in which the electrons orbited in a fixed size and energy, the outermost shell having the most energy, and the innermost shell having the least energy. When an atom absorbed energy, the electron would jump up a level. It would then give off radiation and return to the next lowest energy level. The work of all these men contributed much to our knowledge of the atomic theory today.